Welcome to another Tactical Technician video brought to you from Dive Nation. This is going to be I'm going to call a scope, an intermittent scope drill. So we're going to just look at a true intermittent on the run, kind of watching it as the circuit kind of comes and goes. We have 4 channels, and I will give you the schematic. Just take a good look and take a screenshot of this. Basically, we have the Motronic relay. We have the Motronic PCM. We have a 4-channel scope. Our 4 channels are is at the PCM, the control of the relay, where the PCM would control the relay and make it latch. B is at the feed to one of the fuel injectors. C is green at the relay itself, at the control output of the relay, and D we're going to put the current clamp in 2 different positions with the same actual problem and see what the scope pattern looks like. The first shot of the current clamp is at the control wire between the relay and the Motronic PCM. In between the relay and the PCM, you see that green little section where I have an arrow pointing. That's our problem. That's our intermittent bad connection, bad solder joint. Green crusty's got in there. So just take a good look at this. You could take a screenshot and then kind of keep this with you as we roll through the scope captures. Okay, so you look at your screen, and we have I guess I'll show you the top one is red. That's the feed to the injectors, which when the car is running good, we're strong here. We have full voltage here. That'd be about 14 volts. Blue is at the PCM itself, which is when we're good. We actually have a low voltage. That's basically the voltage drop across the transistor in the PCM when current's flowing. Speaking of current, that is yellow. That is the current flowing through the relay coil, through the PCM driver. That's about 120 milliamps, just enough to create a magnetic field to latch that relay. Green is at the relay itself. When the current's flowing, the voltage is low. Basically, it should mimic blue. And then when we come open, it's a different story. So as we can see, our little glitches here, we're driving along, and all of a sudden the car hiccups. And we can kind of look at our schematic, and then we can determine why. We've lost power to the injector. We've lost current flowing through that relay. We're high on green because, as you can look at your schematic, look where that problem zone is. We've open circuited there, and our blue will remain actually low, which appears to be right here. There's no voltage drop, basically. There's no current flowing in that circuit, so it doesn't have that look of, I don't know, how should I say, a dynamic look right here as it does here. But nonetheless, we determined that to be our source spot in the connector. As you look at your schematic, you can see that, and that could make a car buck. And then it happens again. We lose it at the injectors. Same thing, current stops flowing. Relay unlatches. Our voltage goes high on green because the voltage sort of deadheads into the green channel because it doesn't go low because there's no current flow. So basically, we look at this, and it all kind of makes sense very quick. It's very fast. That's not a long time. The duration of that. Let's see if we can get that glitch. I got a little issue with my back screen, but I'll kind of get close. It's going to be about, oh man, oh wow, that's 27 milliseconds. That is a short period of time, and you're not going to see that on a scan tool. Here it's probably a little longer, but nonetheless you can see that intermittent coming and going. So as you look at your schematic now, we're going to move, just make a change of our channel D. We're going to put that current clamp around the feed to all the injectors. It's the same actual problem. The problem is still with us, so we just want to see what that capture would look like. I'm going to go to a new screen and pull it up and take a look at that. So that was done, okay, right here. So we're going to see, there it comes. Okay, we can see it pretty much here. See similar situation. Now we have that dropout. We've lost the power to the injectors. Blue still stays low because there's no current flowing. Green will go high like it did in the previous capture. You You can see green going to full voltage here, and we've lost a couple of, how should I say, how long did we lose the fuel for? Going to all the injectors. That is about roughly, okay, 40, what do we got there? 400, that's about a half a second. And that'll make a car, could make a car stall, could make a car buck. That driver's gonna feel that. Over here, same thing. We lost all the injection because there's no power going to any of the injectors. So we see that open spot. That's basically our current ramp right here. That's our fuel injectors. I don't know if we have a pintle hump. I've just, nonetheless, a little bit here, but I just want to key more in on the intermittent nature of the problem. And as we keep going down, we know that green sore spot on your illustration, on your schematic, is definitely causing this, where it says problem. You solder joint, connection issue, some broken wire intermittently making connection, which definitely caused this. So that's the power of a scope that when we set it up to kind of like a trap that we know we want to catch, we can see the effect of one problem on each channel is affected the way we have it set up. And it may not be the first time you say, you got to kind of work the schematic and look at the probability of what's causing what. It may take a few captures to get your issue, but nonetheless, thanks for watching.